Module 1, Lesson 3 covers frequency distributions and their graphs. In your textbook, this is covered in section 2.2. Let's first look at what a frequency distribution is using qualitative data. There's a big difference in how we would create a frequency distribution if we're using qualitative versus quantitative data. So let's start with the easier case first. So suppose we sent a survey out to a class, and one of the questions is, what's your eye color? Well, if you think about the responses there, the responses are going to be qualitative, and there's not going to be very many different responses. Some students may have brown eyes, some may have blue eyes, hazel, green, these are probably most of the different responses that you would get. And so what you could do is, for each different answer, count the number of times that that occurred and create a frequency distribution based off of that. And that's basically a frequency distribution, and it's the simplest form of a frequency distribution because it is just for qualitative data, and there's not much else we could do. Situations that we might run into is, if there was a bunch of different responses for the eye colors and you had frequencies all of 1 or 2, then there really isn't much we could do there. But for the most part, for qualitative data, this is all that occurs. Now, let's assume that we ask a different question. And so let's say we ask on the same survey of the class, how old are you? Well, you'd certainly get different responses, but these responses would be quantitative. So you'd get, possibly a list of values, depending on the class itself, but you would get, quantitative data. And unfortunately, kind of like the difficult case with the qualitative data, in quantitative data, you almost always have different values. And so if I tried to put this in a frequency distribution in the same way that I did the eye color, I would end up having a whole bunch of different categories and a lot of frequencies of just 1 or possibly 2. And so when it comes to quantitative data, we have to go a different route. So what we're going to do is we're going to try and limit ourselves to, say, 5, 6, 7, however many different classes we want to use. And each class is going to be a range of values. So like the students between, say, 17 and 21 would go in the first class. And then we would note the number of students in our data set that are within that range. Or possibly the next could be, say, 22 to 25, and so forth. And that way we can get just a little bit better distribution of the data. Now, in order to do that, we first have to figure out the class width that we're going to use for each of these classes. So let's say we decide on using 5 classes, for instance. What we need to make sure of is each of the individual classes have the same number of possible values that would fit into each range. So we need to come up with a class width to determine that. So that's what we're going to do next. There's a formula for calculating the class width, and that formula is to take the maximum data entry minus the minimum data entry and divide by the number of classes. So here is the data set, the 23, 35, 14, 38, so forth. And I went ahead and marked in red the ones that were the minimum and the maximum, because we're going to need those in the calculation. The minimum of this data set is 14, the maximum is 51. If we're going to use 5 classes, and that's something that you can choose, although the homework and the tests will tell you how many to use, but you generally get to choose how many classes you want to use. But we're going to use 5 in this example. So what I want to do is take 51, which is my maximum, minus 14, which is the minimum, and divide by 5. And if you plug that into a calculator, the result there is 7.4. Now, 7.4 evenly divides the range of my classes of my data. And the issue there is my final distribution is going to look a little bit, I don't want to say ugly, but it's not going to look, it will look better if everything was integer based. So we want to round this class width to the nearest integer. And there is a special rounding rule when it comes to class width, in that you always have to round up to the next integer when you're calculating class width. And I have an example at the end of this video which kind of shows you why that is. But for now, just remember that you always round up. If you get a decimal, you'll always round up. So in this case, 7.4, we would round it up to 8. So even though your standard banker's rounding rule says, 0.5 and up, round up, 0.4 and down, round down, we're overriding that rule. We have to use just if there is a decimal, you round it up. If it was 7.1, we would round to 8. If it was 7.001, we would still round up to 8. So if there's a decimal at all, you round it up. Now there is a special case of the class width. And this happens when your class width ends up not having a decimal. It just becomes an integer. And if the class width results in an integer, then you don't need to round up. However, the last class will need to be extended by 1 so that the maximum data entry can fit into the distribution. Some textbooks treat this differently. Some textbooks will have you round it up even if it does result in an integer. I've always used the rule of not rounding if it's an integer and then extending the last class by 1. However, I've got an example at the end of the video that kind of explains all this, so wait until that to see the explanation of how that works. Let's talk about how to create our class limits. Well, in order to create our class limits, what we're going to do is start with the lowest data entry. And in our case, the lowest data entry was 14. Now, we calculated the class width to be 8. So what I'm going to do is I'm going to add 8 to that 14, which is going to give me 22. That's going to be the next lower class limit. So it's going to be the lower class limit of the second class. Now, it's very tempting to put that as the upper class limit of the first class. After I get this created, I'll try and give you some intuition as to why that doesn't work. So this is the pattern that we follow. We start with the lowest data entry, add your class width, and that gives you the next lower class limit. You add 8 to that value, which gives you the next lower class limit. If you add 8 to that value, that gives you the next lower class limit. And we have 5 classes, so we repeat this 5 times. So once we're done adding 8 in a row like that, our class limits, the lower class limits, will be 14, 22, 30, 38, and 46. Now we'll go back and get the upper class limits. And the way we do that is, well, the second class begins at 22, so therefore the first class needs to end at 21. And that way there's a spot for every possible data value. And you could say that the third class then begins at 30, so that the second class has to end at 29, or you could just add 8 to the upper class limit that you just found, and that will get you to the 29 as well. And then you can just continually add 8, which is your class width, to get the rest of these values. Now, between 14 and 21, it looks like there's only 7 possible values there, because if you take 21 minus 14, that gives you 7. The problem is there's what's called an off by 1 error. An off by 1 error occurs quite a bit in mathematics, depending on whether you're counting with the 0th set element or with the first set element. So in this situation, we're counting starting with 0. So 14 is the 0th value in the class range from 14 to 21. And if you count all of the values, 14, 15, 16, 17, 18, 19, 20, and 21, there's exactly 8 of those. So it just depends on where you start your counting. Next, what we need to do is fill in the data into our class ranges. So I tend to do a set of tally marks. And what I do is I start with the first data item, say 23 for example. And if 23 is my first data item, then that fits into the class range of values that are between 22 and 29, which is that second class. So then I put a tally mark in for that. Then I come down to the next data item, which is 35. 35 is between 30 and 37, so that's going to exist in the third class. 14 is between 14 and 21, so that's going to be up in the first class. And I just keep creating tally marks for each one of the data items until I get through the entire data set. And when that happens, I then will add up those tally marks and create frequencies. So in the first class, I had a frequency of 5. In the second class, I had a frequency of 8. The third class, I had a frequency of 6. And the fourth and the fifth classes had frequencies of 3. So when you have your final answer, you don't actually need to put the tally marks into your final answer. You can get rid of those, and your final frequency distribution just needs to include the classes and the frequencies. So it's a little bit more difficult to create a frequency distribution for quantitative data, but this is what we have to do, because otherwise we end up with a whole bunch of frequencies that are 1 or maybe 2, and you don't really learn much about the distribution that way. Next, let's talk about what's referred to as an extended frequency distribution. So an extended frequency distribution just adds additional columns of information onto our frequency distribution, each having its own benefits. We'll start with what are called midpoints. And the midpoint is the middle value between any lower and upper class limits in a given class. And the midpoint is found by just taking the lower class limit plus your upper class limit divided by 2. So essentially you're just averaging the lower and upper class limit. Class boundaries. These are a half unit less than the lower class limit and a half unit more than the upper class limit. So if you take the lower class limit minus 0.5 and the upper class limit plus 0.5, that'll give you the class boundaries. And the class boundaries I don't really discuss much, because they are helpful when you're giving a graph. When you're labeling the x-axis, you can use these so that you only have to label with 1 point instead of a range of 2 values. But other than that, I've never seen much application for them, so this is the last I'm going to refer to them. Other things in an extended frequency distribution: relative frequency. And relative frequency is just the percent of the total data within each class. So to do relative frequency, just take the individual class frequency divided by the total number of data items. And that's going to result in a decimal value, but decimals are very easily changed into percentages, sliding the decimal 2 spots and adding a percent sign. So depending on how your instructor wants the answer, you can answer one way or the other. And it should be stated in your homework or in your test what they want you to do. Cumulative frequency is a running total of each class frequency, starting with the first class. So let's walk through each of these with the distribution that we came up with and get an idea of how they're created one by one. Starting with the midpoints. So the midpoints, unfortunately, PowerPoint's animation is not great. So I have the midpoints up here, but let me show you how I actually calculated the midpoints. So remember the formula. It's the lower class limit plus the upper class limit divided by 2. So for the first class, 14 is the lower class limit, 21 is the upper class limit. If I take 14 plus 21, that's going to be 35. If I divide that by 2, then I will get 17.5. And that's what I have listed in the chart for the first midpoint. For the next one, I would take 22 plus 29, divide that by 2, and I get 25.5. The rest of these can be calculated in a similar fashion. You could take 30 plus 37 divided by 2 and get 33.5, for instance. But if you'll notice, if you take the difference between 25.5 and 17.5, you get 8, which was our class width. And it's no coincidence that the midpoints are off by the class width as well, because if the lower class limits are all off by 8, the upper class limits are all off by 8, then the middle of those ranges should also be all off by 8. So truthfully, you can either go through and calculate each midpoint separately, or you can calculate the first one and then just add your class width repeatedly to get the rest. Relative frequency. Relative frequency formula looks like this. You take the class frequency divided by the total number of data items. So let's get the total number of data items. So if I take 5 plus 8 plus 6 plus 3 plus 3, that's going to all add up to 25. Now, for the first class, the relative frequency there, I'll take the class frequency, which is 5, divided by the total frequency, which is 25. So 5 divided by 25 is 0.2. So you can answer as 0.2 or 20%. The next class has a frequency of 8. So if I take 8 divided by 25, I get 0.32. And I can just continue doing this for the remaining classes, and that's where the rest of the values have come from. So for the third class, the relative frequency is 0.24. For the fourth class, it's 0.12. And for the fifth class, it's also 0.12. For cumulative frequency, it's a running total of the individual class frequencies. So I have them listed here, but let me show you how I come up with them. So I start with the first class frequency, which is 5. Then I take the next class frequency, which is 8, and I add that to the 5. So 5 plus 8 gives me 13. Now, the next class frequency is 6. So if I take my 13, add 6 to that, then I get 19. Then if I take the 19, add the next class frequency, which is 3, that gives me 22. And then 22 plus the next class frequency, which is also 3, gives me 25. So that's the cumulative frequency. And if you put that all together, now we have the extended frequency distribution. Didn't include class boundaries because, as I mentioned before, I don't use them very often, and I don't find much need for them. So I only discuss midpoints, relative frequency, and cumulative frequencies, as those are used much more often. Next, when it comes to graphing frequency distributions, we have a particular type of graph that we exclusively use, and that's called the histogram. And the histogram is a vertical bar chart where each bar represents a class from a frequency distribution. The x-axis can be labeled using the midpoints, class ranges, or the class boundaries. And the y-axis can be labeled using either the frequency or the relative frequency. So generally what I do is I label the x-axis with the midpoints, because again, the class boundaries I don't generally use. The class ranges, what they do is tend to cramp up the chart because you have to put 2 values per bar. So it makes your chart look a little bit cramped. So I prefer the midpoints. All of them represent the x-axis values equally well. The y-axis, the frequency or the relative frequency will give you the same shape of distribution, although your scale will be a little bit different. But let's take a look at an example histogram that's using the class ranges versus the frequencies. So the chart that we've been using is listed to the left, the frequency distribution we created, and then the histogram for that chart. So each class range, so starting with the first class, is listed 14 to 21, then 22 to 29, 30 to 37, and so forth along the x-axis. Those values are categorical, so you just list them. And then the vertical axis is scaled because the frequencies are a type of quantitative data. And anytime you put quantitative data on a chart, you need to make sure your chart is scaled to include all of the different values. So I chose to use the scale going from 0 up to 10, counting by 2s. And then the height of each bar is determined by the frequency that exists in each class. Notice a couple of things here. Number one, the bars are touching. All right, that is something that is important for histograms. We'll talk about why that is in a later example. And there are labels on both your axes, and you have a title as well. So the labels on your axes can be very simple. You can just say whether you're using midpoints, class boundaries, or class ranges. However, if there is some sort of context to the problem, maybe you include, that these are ages of students or something like that. But generally, you can put that in the title, and that would be fine. Then the frequencies, you can either label as frequency or relative frequency, whichever you use there. And then the title, if there's some sort of context to the problem, you can put the title up there and include that context. So I just put that this is an example histogram just so you see where the title is, but you could put that these are ages of students, for example. Example 1. The following data represents the weights of 19 different fully grown dogs at an adoption agency, given in pounds. Create a frequency distribution using 6 classes. Well, to begin, the first thing that we need to do is scan through the data and determine what our minimum data value and our maximum data value are. So looking through there, I see the minimum to be 8, and the maximum is the 59. And we need those values because we are going to plug them into the class width formula. And the class width is equal to the maximum data entry minus the minimum divided by the number of classes. So in this case, when I plug that in, I'll come over here to my calculator, I would do the maximum, which is 59, minus, let me bring the screen shading down a little bit, minus the minimum with it, which is 8. I'm going to go ahead and press enter and calculate that because if I tried to do this all in one operation, I would need to put the numerator in parentheses. All right, and then divide that by the number of classes that we're using, which is 6. So we come up with 8.5, but remember that the class width is always rounded up, and in this case we do round up to 9. So the class width that we're going to use is 9. Now I need to create my classes, and in order to do that, I'm going to start making a table. So here's the table that I'm going to use, although I need to edit it and start including some information into it. I went ahead and included a column for tally. I'll use that in just a moment. So let's go through and calculate the class ranges. So the class ranges, we always start with the lowest data entry, which in this case is 8. And the next class, what I'm going to do is I'm going to take my class width, which is 9. I'm going to take 8 plus 9, and that's going to give me the next lower class limit. So 17 goes here. Next, I continue this process, just keep adding 9, and get the remaining lower class limits. So 26, and then when I repeat the process, the next one is 35, then 44, and lastly 53. Now, the upper class limits is what I come up with next. So my second class begins at 17, so my first class needs to end at 16. And likewise, my third class begins at 26, so my second class needs to end at 25. But if you'll notice, 16 plus 9 gives you 25. So you can actually just keep taking, say like where I'm at so far, and keep adding the class width to that to get the remaining upper class limits. So 25, then 34, 43 is the next one, 61, 52, and 61. And that's all 6 of them, so I know I'm finished there. So now I have my classes created. Next, what I want to do is start entering tally marks for each of the data items so that I can come up with the frequencies. So let's do that. Okay, beginning with the very first data item in the set, which is 19. That's going to be between the values 17 and 25, so I know that I have a value in my second class. So I'm going to put a tally mark there. Then 51 occurs in the fifth class, the range from 44 to 52. So I have a tally mark there. 25 is here in the second class. 11 is in the very first class. 8's also in the first class. 21 is in the second class. 24 is there as well. 53 is in the last class. Then 14. And I'm just going to keep plugging these values in where they fit into the data ranges until I get finished with them all. 19, 59, 42, 38, 16, and 29. All right, now my tally marks don't look that great, but they're perfect for determining just how many values are actually in each group. So my frequencies are going to be 4, 6, 2, 3, 2, and 2, it looks like. So let me enter those. All right, and there is my frequency distribution. Example 2. Use the frequency distribution found in example 1 to create an extended frequency distribution. That is, find the midpoints, relative frequencies, and cumulative frequencies. So I've already added some additional columns to my table so that I can place those in. Let's begin finding midpoints. So midpoints are found using the formula shown here. we take the lower class limit plus the upper class limit divided by 2. So for instance, for the first class, the lower class limit is 8, so I'll plug that into my calculator. The upper class limit is 16, plug that in, add those together, then divide by 2. So my midpoint of the first class is 12. So I will plug that in. For the next class, the lower class limit is 17 and the upper class limit is 25. I'm going to add those two values together and then divide by 2. And you do need to be careful. You can't type 17 plus 25 divide by 2 like that and try and do it all in one line. This will do the 25 divide by 2 first and then add 17, so you'll get a completely different answer. If you try to put them all in one line, you would need to put the numerator in parentheses. But what I find easiest, add them together first and then divide by 2. Either way, the result should be 21. So let me input that. Now, if you'll notice, the difference between these two midpoints, if you take 21 minus 12, that is 9. And it's no coincidence that that is the class width that we were using. So, in fact, you can just find the first midpoint and then just repeatedly add 9 in order to find the rest of the midpoints. So I will plug the rest of these in. And there are my remaining midpoints. And you certainly can go through and use this formula each time. It just is a little bit easier to just get one and then continually add 9 to get the rest of them. And if you aren't sure what the class width of a distribution is, like if I didn't know already that the class width was 9, you can always find the class width of a distribution by taking the difference between any two consecutive lower class limits or upper class limits, and that will give you the class width. One thing you can't do, however, is take, like, say 8 plus 61 divided by 6, because that may or may not result in the class width. This only works if you're working with data. So the problem is, this value is not necessarily the maximum data entry. This one down here definitely is the lower data entry, but this isn't necessarily the maximum. It could be a little bit larger than the maximum. So that won't necessarily work. So if I take 61 minus 8, a second ago I did plus 8, which was a mistake, and then divide by 6, I get 8.83, which does round to 9. So in this case, it does work, but it doesn't always work. So if you want the class width of a distribution, just take the difference between any two lower or upper class limits. All right, relative frequency. The formula for relative frequency looks like this. And it's just finding percentages, so it's not really even technically a formula, but it's fine if you want to think of it that way. We do need the individual class frequencies, which are given, but also the total of all the frequencies together. So if you take 4 plus 6, that's 10, 12, 15, 17, 18, 19. So the total of all of these is 19, so that's what I need. Now, each individual relative frequency is going to be, like, for instance, for the first class, if I take 4 divided by 19 and come over here on the calculator, so 4 divided by 19 gives me 0.2011, and I'm going to round it to 3 decimals, but just pay attention to whatever the instructions are on the test or homework you're doing. 3 is usually just fine. So 0.20 or 211. So that would be the relative frequency of the first class. Of the second class, I would take 6 divided by 19, and 6 divided by 19 looks like I get 316. And then if I want the next class frequency, 2 over 19, I'm sorry, the next relative frequency, 2 divided by 19 would give me 0.105. And then I'm going to do the rest of these real quick. So the remaining class frequencies, 0.105, 0.158, and these last two here are 0.105. Because the frequencies are the same for those. So there are my relative frequencies, and I think I'm going to start with the cumulative frequencies next. Those are pretty straightforward. You just start with the very first class frequency, and that's your first cumulative frequency. Then you add the next class frequency to that, and that's your total so far. And that's your cumulative frequency. So you're allowing the frequencies to accumulate. And then 10 plus the next class frequency gives you a total of 12 so far. Then if you add 3 more to that, that gives you 15. 15 plus 2 gives you 17. And 17 plus 2 more gives you 19. And there are the cumulative frequencies. And that's all there is to it. Number 3, create a histogram for the distribution using midpoints along the horizontal axis and frequencies along the vertical axis. So I've copied our distribution over again, same one that we've been using in the past 2 examples. I also included the midpoints because we're going to use those along the horizontal axis. And so let's go ahead and get started creating our histogram. So the first thing that I need to do is to create an axis. And in creating an axis, what I'm going to do here is scale using text values. Because if I am labeling categorical data, and these classes actually are categorical, then the axis is just listed with what those values are. So even though the midpoints are technically quantitative values, they're still categorical. So I can just list those values as such, and that's horizontal. All right, there's my lower axis. So that's all set. Spread it out there. All right, and I'm going to go ahead and label that I used midpoints along the axis, the lower axis. Next up, I need a vertical axis as well. The vertical axis is a little bit different because I need to scale that axis. And I'm scaling it because frequencies are definitely quantitative values. Anytime you're using quantitative values, you have to scale your axis. So, like for instance, I could do from a minimum of 0 up to say 8 and scale by 2s. All right, and I'll just place this over here, make it fit. And that'll be fine. It doesn't really matter. All right, and I'm going to label this with frequencies. Unfortunately, I don't have the ability to do text that is vertical, which would certainly look a lot nicer, but that's okay. And before I draw my bars, I'm going to go ahead and put a title in here as well. It's been a while since we gave context to this problem, but these were weights of dogs at an adoption agency, so I'm just going to leave it weights of dogs. And now we've got everything appropriately titled here, so let's draw in our bars. So the bars are dependent upon the frequencies, so let's start with some rectangles. Okay, and this isn't going to be the easiest thing to do, but I will do my best here. So the first class has a midpoint of 12 and a frequency of 4. So I need to draw a rectangle with a height of 4. Okay, and I'm bringing this over as close to about the halfway point as I can because I want the rectangles to touch in the end. All right, now the next class has a midpoint of 21, a frequency of 6. So I'm going to need a rectangle here of height 6 and about the same width. They should be the same width, but like I said, that's going to be difficult to do here for me. So I'll do my best. All right, next up, the next class is 30, and there's a frequency of 2 there. So just make that a height 2. The next class has a frequency of 3. So I will draw in approximately where 3 is. And then the next class has a frequency of 2, and the last class has a frequency of 2. And so now I've drawn an appropriate histogram for this data. Now these next few examples, I just want to show you some of the intuition as to why we set the rules the way we do when we are creating our class ranges. So we're going to create class ranges for a set of data that has a maximum of 55 and a minimum value of 10 using 5 classes. So let's get started here. So the class width, remember its formula looks like this, is going to be calculated by taking that maximum value minus the minimum value and then dividing by the number of classes that we want to use, which in this case is 5. So the class width in this case ends up being exactly 9. So we don't have any rounding to do. Now, here's what happens when we calculate the class ranges. So we start with the lowest data entry. That's always going to be the beginning of our first class. And then we add to that the class width. So 10 plus 9 is going to give me 19, and that gives me the next lower class limit. 19 plus 9 is going to be 27. Oops, 28. And if I continually add 9, I'll get the rest of these lower class limits. So 28, 37, and the last one is 46. Now, let's get our upper class limits. So if my second class begins at 19, my first class needs to end at 18. Similarly, the next class ends at 27, and then the next class at 36, then 45, and if I add 9 to 45, that gives me 54, so that's the last class. But if you'll recall, the maximum data value was 55. This last class isn't long enough to contain that value. And so this will always happen whenever your class width does not have a decimal. It'll always just be off by 1. It's another off by 1 error. So to correct it, easy thing to do is just extend that last class by 1. An alternative way of doing this is instead of going this route, if we take the class width up to 10, let's take a look at what happens then. So then my classes would look like this. So they would start with 10, And then the next class would begin at 20, then 30, then 40, and then 50. And my first class would end at 19. The second class would end at 29. The third class would end at 39, then 49, and finally 59. So at that point, this is an alternate way that some textbooks go. I do have room for the 55, but if you'll notice, I've kind of maximized my error in the very end. So I have 4 more data values than what's necessary. So my preference is this route right here, but some textbooks go this way. So their rule is just no matter what, even if the class width divides evenly, you still round up. But all the homework and tests will be using this method right here. In the end, you do have a choice as to what you want to do. All right, now in this last example, number 5, I want to show you why we have to use the rounding rule that we do when it comes to class width. We always have to round up, that is. So create class ranges for a set of data that has a maximum value of 62 and a minimum value of 13 using 6 classes. Okay, so my class width formula, same as what we've been using. So class width, I would do 62 minus 13 divided by 6. Now, the class width, we would round up to 9. Even though this is 8.1, I would still round it up to 9. However, I'm going to do this once by rounding to 8, just so you can see what happens. All right, so if I use a class width of 8, let's see what happens here. So the very first class has to begin with my minimum value, which is 13. The next class, I would take 13 plus 8 and then continually add 8 to get the remaining classes. So 13, then 21, 29, 37, 45, and lastly 53. I know I have 6 classes this time, so I need 6 numbers. All right, so then these classes, the upper class limits, will end at 20, 28, 36, 44, 52, and this last one would be 52 plus 8, which would be 60. So here's the thing. Whenever you round a value, you're introducing error into your calculation. And so that error propagates for each one of these class ranges that we create. So 8.1666, and so forth, that is the value that would evenly distribute all of these numbers. Since I decided to round down, I made each class a little bit shorter than what it needs to be in order to fit all the data. So that remaining values has kind of propagated, and therefore I now have not enough room for all of my data. So I need to have a maximum for 62. So that simply doesn't work. So going this route is unfortunately incorrect. So we can't do that. All right, so now we have to come over here to where our class width is rounded properly, so we round up. Again, we're introducing error, but we're introducing more space than what we need so that we can end up having enough room for all the data values in the end. So let's see what happens now. So the class width of 9, creating some classes, we begin with the minimum of 13, and we start with 13 and add 9 repeatedly to get the rest of our classes. So 22, 31, 40, 49, 58, and that should be it. And now I'll go back and do the upper class limits. So 21, 30, 39, 48, 57, and then if I do 57 plus 9, that's going to give me 66. So now this value is larger than what I need. I only needed 62, but at least I have room for all my values. So if we're going to introduce error into the calculation, we want to do so in such a way that we still have room for all of our values.